Hello friends, it has been a long hour. I have been working on big data part, Hadoop to be more specific. Initially I was struck with the configuration because I'm working on the Hadoop, the most latest version, Hadoop 3.4.0. There was a good number of hours I have to spend for the configuration part, and finally I did the configuration and it's working well. I'm not talking about the configuration step because that's a totally separate subject altogether. I have to show you different files and all the instructions which I have written to make the configuration successful. But what is our sole focus is, like, once you have implemented Hadoop and if it is working, then you start working on the coding part, and the code that you will be writing is in Java. Undoubtedly it will be in Java, but the primitive data types which you have used in core Java, those things will not work over here. Rather, Hadoop has got its own classes, and that's what we have to make use of its own data type. So in this particular program you will be able to figure out some of the data type that Hadoop has generated and how they are going to work. Now the first thing is that let me check and let me show you. Let me come to the DOS terminal, and over here let me show you that Hadoop version, just to see whether everything is working fine or not. And the other version is version 3.4.0. that's the latest version. Okay, now I have to start the Hadoop daemons, which is not yet started. That's the reason. If I come to the browser and if I go to localhost colon 3870, if I refresh, it's saying no page found because the services or the daemon are not yet activated. So let me start the daemon. So first thing what I will do is that I have to go for Hadoop distributor file system, DFS. So start -dfs .sh. So this would be starting three different daemons. One is the name node, then the data node, and third one is the secondary name node. Yes, so these three nodes it is going to start, and this is a very important part, as I already said at the very beginning, that once your config is successful, then only these things would be activated, otherwise they will not get activated. Okay, be sure about that. So once this thing has started, now you can just go and verify whether these daemons are working perfectly well or not. For that reason, there is a command called JPS. With the help of that command, you will be able to figure out that whether these daemons are all working successfully or not. But we have to wait a little bit. Once this thing has got started, yeah, see, everything is now fine. So we can go and check out JPS, Java process system, and it will be showing that data is node is there, name node is there, JPS itself is there, and secondary name node is all working. Now apart from this, you also need something called yarn. So start, just a second, start -yarn .sh. So this would come up with, sorry, start.sh. So this will start with the resource manager, and the yarn will be responsible for generating, as I said, resource manager and the node manager. That means it will be responsible for providing the memory management so that the processor works smoothly. That is what the yarn takes care about. So all total we have got 5 main daemons that are going to work. That is called name node, data node, and secondary name node, plus resource manager and node manager. Let me clear the screen and let me fire JPS once again to show you that all these 5 processes is working. See over here, resource manager, node manager, data node, gems, name node, JPS, and secondary name node. So it is all set to go, and now we can go to the browser and we can reload the page, and you will find that the Hadoop distribution system has started. See, it is now working, and it will now be visible. Yeah, it's already got visible. So just like the way we have got Windows operating system, we have got Linux operating system, we have got Mac operating system, in the same way Hadoop has also got a distributed system, and it has got its own file format. So inside that file format you can store different resources by Hadoop. Like if you come to the utilities portion, and in the utilities, if you go to the browser file, these are some of the resources which is already present, which I have actually installed inside the distributed file system. And over here I have a folder called user, and that user folder has got another folder called A, and inside that there is a file that is called import.txt, which I will provide in the source code right now in the program. But this output hyphen directory, this is a D, so it's a directory. I don't need this right now because the time when I will be working on the actual application, if this particular folder is present, then it will not generate the right output. So what I will do is that I will remove that folder. So how do I remove it? With the help of Hadoop. So Hadoop will provide a series of commands. So Hadoop DFS, distributed file system, equals to, I'm going to remove it, so rm, and inside that there will be some files that also I want to remove it, so -r for recursion, so it will delete all the files that is present inside, and then the folder name is output, and followed by what is the, let's check the spelling once, output followed by directory, directory, and I hit the enter, and this is going to delete the application. Yeah, see, yes, deleted output hyphen directory. So if I come and if I reload the page, so the output directory, which folder which you just now saw, won't be there anymore, and as I can see, it's not there anymore. Okay, so that particular folder will be responsible for storing the result, so that whatever computation Hadoop has done, that will be stored inside that particular folder. So that's the reason I deleted the folder, so that a freshly new folder can be created, inside which we will be getting all the output. Now let's come to the actual core part, and that is the most important thing, that why are we working on Hadoop? Because Hadoop will give us an environment where we can perform multiple tasks at the same time. So an asynchronous communication, a parallel computation, both these things are being possible in case of Hadoop. So a very popular Hadoop program, that is a word count, that is there, which I have also done it, and here is my Eclipse. So with the help of Eclipse, I'm working on Hadoop, and for that reason I have to install different dependencies, and for that reason I'm using the pom.xml. Inside the pom.xml I've written the dependency list, which eventually got installed, and that is there inside the Maven dependency. So here if I tap on it, hell lot of dependencies you will be able to see these are all dependencies. And as I said, I'm working on the Hadoop most upgraded version. That's the reason 3.4.0, that upgraded version is also been shown. That is what I'm working. Now whenever you're working on Hadoop programs, or you're working on MapReduce, there are basically three different parts of the program. It would be, the first part would be like a class, which is like a driver class, which will contain the main function. I repeat, there will be a dedicated class which will be containing a main function. Of course this class will be created by the user only. I mean, as a developer I will be creating it. These are not system defined class, but make sure what will be happening is that inside this particular class we are going to write the main function. Apart from this, there will be a couple of more functions, more classes. One is called like a map function, or a class related with the mapping. I will show you what that. And finally the other class would be about the reducer. Okay, so all three classes are very important. Let me show you the sequence in which it will working. The way the program will work is, when I will run this particular program, I will provide a file which is present in the Hadoop distributed file system, which we saw just a few minutes ago. That is the inside the user I have a folder called A, and inside there is a file called input.txt. So this particular file, if I tap and if I open it, you will find there are a few lines of code written over here. Let me show you that. Yes, I hello you, you hello me, he is there, he did hello you. Don't go by the statement. I've written some random word over here, random sentence over here. Point to be noted over here is that I have written hello 3 times, but out of which there is 2 occasions where the hello H start with uppercase, the other one is start with lowercase. So now what I want is that I have got this particular file which I will provide as input during the time of execution, and what my Hadoop need to do is that it has to go through the entire file, and it have to figure out that how many occasions are there where the word hello has been used, and that is what I'm going to trigger. So for that reason, what it would be doing is that as I said, there would be a class called driver which will be responsible for starting the application, which will have the main activity, a main function, not activity. I'm not talking about Android. So it will be having a main function. Now inside this main function, what I will be doing is that first I will create the configuration object of the reference of the configuration, and this configuration is going to give a call to the subsequently two different classes. One is the mapper class, which is right over here, hello world mapper. Okay, this class it will be giving a call. In the same way, it would be also calling the reducer class. So these classes would be called by the respective functions, like set mapper class, set reducer class. Now remember one thing over here, apart from these two, there would be another class, and this is this particular driver class itself. Okay, the part of this. So 3 different classes are there that will be all integrated together with the help of this particular job reference. Okay, so job will be responsible for connecting all the relevant files together, so that we can work as a whole. Now when I will be executing the file, I will provide my file which is there in the Eclipse, not in Eclipse, in the network, rather I will say in the big data network. So this particular file input.txt, I will provide it as an input, and from that particular file it will get the data. and each row it will pick up, and that's what the reducer method, the mapper method would be doing. It will pick up one row at a time from the file, and it will compare that is that row has got any word called hello where H start with uppercase. If it finds so, then it will make like an array, or you can consider like a dictionary where the hello word becomes a key, and it will assign the letter 1 over there because it has found only one time. The next time again, the next row will pick up again, it will go on comparison, it will, if it is true, then it will assign 2, otherwise it will move on. In this way it will go through each of the rows, and eventually what happens, it will create a complete matrix where the key would be the word, that is the hello, and the value would be the respective value what it will find. So this is what the mapping function class would be doing it, and for that reason if you look over here, it has got its own parameters. So long writable key, is means that I will be giving like a file, and from the file it will pick up one value at a time. So that's the reason it's a long one. Now text value is the word hello which is going to search. Okay, so that means inside this, like as I said that I will be giving a file as an input, and from the file it will pick up one data at a time, and then it will go for the comparison like what we are doing over here. So it's comparing that whether the word hello is there. If it is so, then it will create one key value pair where the word hello will be there and the letter 1 will be assigned, the num1. 1 means a numeric value 1. In that way it will assign a key value pair. And finally this particular data will be handed over to the reducer, where it will do what? It will get one array, and from that array it will pick up one data at a time, and it will do the addition. That means how many times the hello reference is there which will have the numeric value, that what it will do, and it will generate the sum, and that sum is finally going to return back, and that return result will be stored where? Inside my big data Hadoop system. Over here, this particular file, class is responsive for storing the data inside the big data, and from there I would be able to get the data back. I will be getting the result back. Okay, so that's how the thing is going to work. But the challenge would be that I have got 3 different classes, like .java one class, another .java, another .java. So how would you run them? You will be running them together with the help of a jar file, and the jar has been already been created. So if I want to show you, the jar file is already there. Let me minimize this one and look over here. I already have got the jar file present. Let me make the screen larger. See over here, I do have the jar file. Okay, so I'm maximizing it, is getting minimized. See over here, I already have created the jar file. So those instructions I'm not showing, otherwise it will become more lengthy. So look over here, I've created the jar file. Inside the jar file, I have got all those 3 classes together. So this is the jar file which I will be executing. And apart from that, what would I do? Like this jar file, as I said, will be having a, within this jar file the class file will be there. That's the reason this output folder is there. So I have created this particular folder. Again I will show you the command. So inside this particular folder, after compilation from the .java file, it will be generating to the .class file. We have got this .java file. So this .java file got converted into .class file, and inside, and all these 3 classes are now wrapped up within this particular jar file. So this jar is the one which actually is like the main resource to be executed. Okay, so how did I now I will be running my code. So for that reason what I will be doing is that I need the terminal, and here is my terminal, and let me fire the code. Let me clear the screen, and remember my Hadoop is already working, big data is already working. So how do I deploy or how do I execute it? So first it will start with the Hadoop keyword. The Hadoop is a command over here, and I'm going to give a call to the jar. What is the name of the jar? The name of the jar is called hello-world.jar. Okay, fine, that's the jar name. Now what I will be doing, I will be giving a call to the respective class, and that class which the main function is there. So that means which class I'm talking about? The very first class, that is called hello world driver.java. So this class has got a main function. This is what I have to call, and now I will be calling that. So what will I do? First of all, before I call, the one more thing I would like to show you, that over here I have got a package called WordCount. Within this package, see over here the word package is there, WordCount. Within that these files are there. So I need to give a call to the package first, and eventually the file will be given a call. So let me first write the package name, that is the WordCount, and then I will not write slash, it will be dot, and then it's the project name, that is called hello. Just a minute, let me write hello. I have to write probably the whole thing. Hello world driver. Okay, driver, hello world driver. So word count is the name of the package. Inside that there is a hello world. This hello H should be in upper multiple hello, right? Yes. So hello world driver. Now this file will get the data from where? From my input txt, which is present inside my Hadoop distributed file system. And once it got the resource, once the computation has been done, now it will generate the output. So for that reason, what I will do is that I will create a new file called output hyphen directory. Well, you are free to choose whatever name you feel like. That's your totally your choice. It doesn't matter. And now if I hit the enter, the application should work, and input should also be available, and everything should be fine. So let me just run the code and let's see what happens this time. So let me hit enter, and as I do that, the deployment will start taking place. Initial screening will be taking place, see over here, and there is some issue taking place. What is the issue? Input path does not exist. The localhost user input text is not available. Why it is not available? I have already written over here. See, saying the user a input. Oh, I made a spelling mistake over here. That it's my mistake. Yeah. Let me clear the screen once again. See, I instead of writing input, I didn't write the letter P over it. That's the reason. Otherwise, it already there in the file system, right? Now I hit the enter again, and hopefully this time it would work. If not, some issue is there again. Let's see now. Execution started. Yes, it's going very well, and finally we got the result. Yes, and look over here. This is the MapReduce framework action coming in picture. So total, how many lines of code were there? There were 4 lines of code. If you remember, I will show you when from the big data. There were 4 lines of code, and inside the 4 lines of code, there are 2 such occasions are there where the word hello is there, where H is in uppercase, and that what it has been figured out. Remember, there was another hello was there where H was in lowercase, so that was not treated. Okay, so that's the result which we have collected, and this result has been stored inside even your Eclipse also. I mean, in your big data also. So let me come over here and let me reload the page, and along with the input, you will find now the another folder called output hyphen directory. So if I tap on this is the file which would actually show me the result, that is part hyphen r. If I tap over here, I will be able to see, go to the head, and from here you can see what is the result. See, hello has been present only 2 occasions. And if you see your output, let's look at back. I mean, if you want to see your input text over here also, you have got 3 hello, but out of which there were 3 hellos. So let me click on the first, out of which the second hello was H was in lowercase, and in my condition I will clearly mention that show me the count would be considered only if and only if where H is in uppercase, then only will be considered, otherwise it won't be considered. Okay, so finally, it's a pretty long video and it's almost 1 o'clock by now. So we saw that how 3 different Java files, the main function, the mapper which is responsible to form the key value pair, and finally the reducer who will count the total number of occurrence of that particular word, and that thing has been passed on to your Hadoop, which eventually will deploy the whole thing in the distributed file system. And as you can see over here, the resources are getting stacked over here inside the Hadoop, and we are using the most updated version of Hadoop, and that is called Hadoop 3.4.0. okay, so finally I come to an end of this particular video where I've shown you that how the MapReduce program is working, and this is what actually you need to understand, and this is what you need to explain in case if you go and apply somewhere. Okay, and this is quite interesting because I just gave you an overall presentation to show you that how the distributed file system is working, but of course you need to go through individually and find out this meaning of these respective classes and how they are working. Okay, so in my next video I definitely will talk about these things more in large scale. This is just initial beginning, you can say so. Okay, so that's all from this video presentation. See you soon. Bye bye.